Write the fraction as a decimal rounded to the nearest hundredth. So we can do 22 divided by 30, which gives us 0.73 repeating, but to round to the hundredths place, that's 2 decimal spots, we look at the one after it. If it's 5 or more, it raises this number, but if it's a 4 or less, it's going to stay. So this is 0.73. You are going to be a contestant on a game show called Picking Blue. Let's see how the game is played. How could you explain the game to a classmate? So the way that you earn points is based on picking a blue. But your turn ends as soon as you draw one red. When you go on picking blue, you get to choose the bucket you use to play the game. Each bucket has the same number of chips. The chips are either blue or red. One bucket has an unequal number of blue chips and red chips, and the other bucket has an equal number of blue chips and red chips. What information do you need before you choose your bucket? I would like to know how many total chips are in each bucket, and how many of those are blue. If I know that there are 10 chips in each bucket and 5 are blue in one bucket and 7 are blue in the other bucket, that would help me make my decision to win. Before you choose a bucket, you should gather some information about the chips in each bucket. Pull a chip from bucket A 10 times. So I pulled a blue, then a red, so you can see my relative frequency is changing. So far I have selected one blue out of the total pools, and they've converted that to a fraction and a decimal. Now I have 2 out of 3 are blue, 2 out of 4 are blue, 3 out of 5, 4 out of 6. Now I see that I have 7 out of the 10 were blue. I know that in one bucket there's the same amount of both, so I would expect in that bucket to get a relative frequency to be about a half, or 0.5. So you may be considering that this bucket has more blue than red, or perhaps it's just the way that our experiment went. It says, based on your results, what is an estimate for the theoretical probability of pulling a blue chip from bucket A? And how confident are you that your estimate is reasonable? I am fairly confident that this is reasonable because 1, 2, 3, 4, 5, 6, 7, 8 of my relative frequencies were above 0.5. So I'm thinking that 0.7 is a reasonable estimate since the majority of them were above half. Pull chips from the bucket until you can confidently estimate the theoretical probability of pulling a blue chip from bucket A. So I might do more than 10. Now, I might say that I'm confident here that it's around 2/5 or 0.4 because it started to level out around that location. You can see that it's flattening out around this 2/5 line, which would be a decimal of 0.4. It says, based on your results, what is the estimate of the theoretical probability of pulling a blue chip from bucket A? I would say that it's about 0.4. It's a little bit higher here, but it was a little lower here. So it's leveling out around this 0.4. Let's explore bucket B now. Pull as many chips as you want until you are confident of your estimate of the theoretical probability of pulling a blue chip. Now it's begun to level out around 0.3. So you may be confident here, but you may want to continue a little bit longer to be sure. You can see it's on that 3/10 line, and 3/10 as a decimal would be 0.3. So which bucket do you want to use to play the game? Well, if the probability of selecting a blue in this one is lower, then I would want to choose the one that has a higher probability of getting blue, which would be bucket A. And now that I'm thinking about it, I would say that since B went to 0.3, I might even change my probability for A to be a half because I know that one of the buckets has the same amount of blue and red chips. So perhaps bucket A is really 0.5 and bucket B is 0.3. You chose bucket A. Play the game at least 3 times to see how often you win. So in that one we tied. And in that one we tied. In that one bucket A won. It says, do you think you chose the right bucket for playing the game? I do, but let's continue to play since it says at least 3 times to see if that pattern continues. This time, bucket B won. Now that doesn't necessarily mean that bucket B has more blue chips. It could just be this one experiment. So in that one, team A won. But that time, team B won. And team A and team B win almost the same amount of times. So do you think that you chose the right bucket for playing the game? In some times, team B was in the lead and had more wins. At other times, team A was in the lead with more wins. So you can't just determine if you chose the right bucket by who is leading, and perhaps maybe 3 times is not enough to determine if you've made the right decision. But I do think that I made the right decision. And the reason is because the probability of picking a blue from each bucket was higher in A. Now, just because the probability of selecting a blue is higher doesn't necessarily mean that we're going to select a blue each time we draw from bucket A. There's still a chance that I could get a red, which impacts whether I win or lose. Here are the results from another class that has also conducted the same experiment. What is an estimate of the theoretical probability of pulling a blue chip from each bucket? You can see here that bucket A is right under 0.5, and then bucket B is right around 0.3. Click to reveal the contents of each bucket. What is the theoretical probability of pulling a blue chip from each bucket? Bucket A would be 5 out of 10, which is 0.5. And bucket B would be 3 blues out of 10, which is 0.3. How do the theoretical probabilities compare with your estimates? I underestimated the theoretical probability of bucket A because I thought it would be 0.4. Create a new bucket for the game. Click the chips to change their color. I changed mine so there were 2 blues, so that would be a probability of 2 out of 10. Or if you wanted to write it as a decimal, that would be 0.2. You said the theoretical probability of pulling a blue chip from your bucket is 0.2. Mark the theoretical probability of pulling a blue chip from your bucket by moving the blue line. Pull chips from your bucket until you feel confident that the relative frequency is an accurate estimate of the theoretical probability of pulling a blue chip. So 0.2 is the same as 1/5. And we're going to wait until our relative frequency line starts to flatten out around 0.2. So for us, it took around 100 pulls for us to get a probability that was around 0.2. You can see that it was below 0.3 much sooner than that at around 40 pulls, but it gets even closer as we go on. The more and more it continues, the closer and closer it's going to get to that 0.2 and stay right around that line. You can see the longer and longer that we continue this, the more it's going to converge to that 1/5 or 2/10. And then that's the end of lesson 8 for probability of picking blue, where we're looking at the difference between experimental probabilities and theoretical probabilities.